Welcome back to Google Day TV Classroom in relation to with what? With e-learning teachers project Uganda. Remember, I'm Kanyike Francis and I'm handling a topic called curve sketching. We are looking at the asymptotes now. How do we determine the asymptotes? Those of you who have just joined us, I want you to know very well that we have already completed how to determine the vertical asymptotes. Kudos to everyone that paid attention, that took notes, that was very much active and took part in this class. I've seen people from Karangala, people from Masaka, people from Jinja, even here in Kampala, Wakiso, you know, every bit, Mubende, Mukono, Jinja, people that are even as far as Rira. I like the fact that you've been paying attention and you've been a part of this lesson. Let us move on now. Remember, we stopped or we ended with finding or determining the vertical asymptotes. And I told you that when we come back, we're going to handle the horizontal asymptotes. If you remember, when we defined the vertical asymptote, we said that the vertical asymptote is the value of x that makes y tend to what? To positive or negative what? Infinity. Meaning that we were obtaining values of x. If you go back and check what we've done, you're going to discover that we've got values of x representing the vertical asymptotes. Beautiful. Now, when I come to the second part, remember we said there are three types of asymptotes. But the second type of asymptote is what we call the horizontal asymptote. Horizontal asymptote. Ladies and gentlemen, I want us to quote something very important here. It is important for us to know that where the equation of the curve was presented. However, before we even look at that, we must understand that the horizontal asymptote this time is the value of what? Is the value of y. Is the value of y, meaning that the horizontal asymptote must always appear as a value of y. And this value of y, therefore, does what? Does one thing. It makes what? It makes our x do what? Tend to infinity. It is very important. There are values of y, or is a value of y that makes x tend to infinity. Wonderful. So you see, every time you find the horizontal asymptote, every time you get the horizontal asymptote, I want you to understand something very important here. You're obtaining values of y. And in this case, therefore, we're going to use two methods to determine the horizontal asymptote. Are we together? Very good. Now look at this example we've just put here. You see, they presented to you an equation of a curve given as y equal to x minus 3, the whole of it to a square, and then divided by what? By x into x minus 5. My wonderful students, those of you who are really watching us now, live on Google Day TV, all right? I want you to know one thing, that you can never find the horizontal asymptotes unless what? Unless you have removed the brackets. Okay? Unless we have removed the brackets. Amazing. Now, I want us to go quickly in our side work and be able to see how do we do this quickly. All right? You see, from O level, some of us may have forgotten. How do we handle this one here? If you've done a topic called binomial theory of expansion, you must be finding this one very easy to do. All right? But let's look at other means, other ways of how we can expand a given expression. You see, this is side work. Side work. All right? Now, look here. If you want to expand x minus 3, x minus what? Remember, I'm picking my numerator here. Why? Because it had a square. You see, this one can also be written the other round. We have x done what? Squared. Are we clear now? It was given to us like that in the numerator. This is the same as doing what now? As writing x minus 3 into again the same x minus 3. There are some of you, when they ask you, 2 squared. Let us make it 12 squared. All right? And then someone gives us a beautiful 24. A beautiful 24. Let me say an ugly 24. Why? Because 12 squared can never be 24. This power here shows us the number of times. The number of times you're going to multiply this base by itself. Remember, this is called the base and this is called an index. All right? So we're going to multiply this base by itself 2 times, meaning you'll be having 12 times what? Times 12. You're such brilliant students. Now, picking this simple concept is basically what we've just done here. You see, you have x minus 3, done what? Done what? Squared. Beautiful. And then we expanded it in this form. We have that one very well understood. I want us to go through, well, of course, there are so many ways of slaughtering a cow. All right? Some people normally hit it on the head. Yeah? Others do it the other way around. You know how they do it in those slaughterhouses. All right? Now, we can use so many ways, so many methods here. I want to give you one other method we can apply, and that's called the tabular approach. Somewhere you draw a simple table. Look at this table I'm drawing. You draw something like this. Please observe critically, and you have this as well. Please observe. All right? This is a beautiful table that we're going to use. I can remove this one here like this, and then close this one up like that, and close that one up like that. All right? It looks like a ladder. It means we are climbing to another level. All right? Now, let's pick each of these brackets one by one. Right, we have this one here. This is going to be our x. In the first bracket, we have 2 elements. We have the element x, and the other element is negative what? Negative. This one must move with the sign. Do not forget that. Wonderful. So we have x, which is this one here, and we also have negative 3. Remember, we are expanding this one quickly. All right? Then the next bracket here has also got 2 elements. One is x, and the other is what? Negative 3. Correct. So we write our x here, and negative 3 there. You can see that the expansion for x minus 3 done what? Squared needs what? We need these 4 steps. All right? And we're going to go and handle each of them independently. Look at this. To fill up these 4 gaps, we're going to ask ourselves, what do we need here? Of course, to fill this gap here, you need x times x. X times x, is it what? Is it 2x? 2x? No. Try again. X times x, what is it? It is x done what? Very good. X squared. So x times x is x done what? Squared. All right? And now we have x times negative 3. Have you got it? We are multiplying x times x to get this one here. And also getting x times negative 3, which gives us negative 3 what? X. Beautiful. That is very good. Now you see our x has nothing else here. Now we need now to move to negative 3. The same story is going to be retold. All right? We have negative 3 times what? Times x. All right? Then we have what? This is going to be negative 3x. Clear? Very good. And now look at this. We have negative 3 times negative 3. What happens when you multiply 2 negatives? Do you get a negative? No. You get a what? A what? A positive. Beautiful. So you see negative times a negative. First of all, we're going to have a positive. All right? And then 3 times 3 doesn't give us 6. Doesn't give us 33. It gives us what? It gives us Mr. 9. Are we clear now? So in this simple expansion, we're now going to follow the Z form. Okay? Look, I'm going to start from this x here. I come down here and say, where I have x done what? X squared, x squared. Now from x squared, I'm going to move to the next number, which is negative what? Negative 3x. After this number, I told you we're moving in Z form. Here, we have now, we've landed on negative 3x. Our Z is our Z complete? No. We began from here, went there, came here. That is not Z. We must now land to positive 9. Amazing. Now from here, you do see, you have what? You have x squared. What is negative 3x minus 3x? A negative 3x minus 3x doesn't give us 0. they don't die. This is the common mistake. People cross out. The negative minus another value, okay, would give us a negative first. All right? So negative 3x minus 3x is going to give us negative. You add these two, you get what? 6x. You've handled this ones. Why? Because they come from the same family. So therefore they can mix up, they can join together. Are we together? Now the 9 is going to come back here because it's from a different family. Are we clear now? Very good. So this is the expansion we needed for this part here. So we would say, well, this one is equal to what? This one expanded is going to be x squared minus 6 what? X, all right? Then plus what? Plus 9. Are we clear? Are we paying attention? Are we getting something? This is e-learning teachers project. We remind you to sanitize. Be clean. Always wash your hands. Keep a distance. We need you to be healthy. At the comfort of your home, when you're watching Google the TV, please allow us to take you through the topic of curve sketching. Let me give you another approach we could use, all right? The another approach we could use, if you don't want to use this one here, is called foil. It's called what? Foil. Under foil, what we do is, after writing this one down, then we do this. We draw a line here, all right? And draw another line where? There. And then we put a small box. This must be done in pencil. Have you seen that? And in this case, therefore, what you're going to do is somewhere you write the word foil. Foil. All right? And then I come down here. Don't look at these ones, please. Now pay attention to what I'm going to put here. All right? So we shall come and say have x minus what? Minus 3. Then what? Squared. Remember, this is what we are finding. All right? Now we start on our foil. We began by expanding it, and we did this one here. Forget about the table for now. We looked at another way of expanding it quickly. Now, F stands for the first ones. You see, each of these two brackets has got a first element. So meaning, I'm going to have, this one means first. First. Meaning, I'm going to get the first value, which is, the first element is x, times the first element in the other is also x. Are we together? Giving us what? Giving us a beautiful x done what? Squared. Now that must be followed by what? By those ones out what? Outside. Outside the box. We drew this box here, but we have some two elements that are outside. Are we together? We have x and negative 3. So you multiply x times negative 3 to get a beautiful negative 3x. Are we going together now? Are you following? Are you learning something? Are you getting it? Very good. Let's move on. The next one, the I, stands for what you call inside. Okay? What do we have inside the box we drew? Of course, we have negative 3 and x. When you multiply the two, negative 3 times x is going to give us negative 3x. I hope you see that we are now getting what we got here. Isn't it? Now, finally, L stands for what? For Lydian? For line? No, please, you see we had the first, isn't it? When you have the first, you must have the what? The last. So we have the last ones as well. You see, in these ones here, we have elements that are last in each. So in the first bracket, you have negative 3 as, came as the last one, and also the other has negative 3 as the last one. So multiply these two last elements. Okay? We know we're going to get a positive what? A positive 9, which is basically this here. Altogether, this one here is the same as that. Therefore, if you can have this one here, equal signs in one line, don't forget that it makes your work very neat. Then you simplify like we did to get x squared minus 6x plus 9. Foil is the way to go. Table is the way to go. You can also use other methods, either binomial theory or putting x outside and work on this one. Then you come back and use negative 3 with this one, expand nicely and simply to get your work. Remember, we are not interested in this at A level. We know you must be knowing how to expand. That's why I'm doing it as side work. Okay? Now let's come back to what we are doing. All right? We are back here. Ladies and gentlemen, we are back here. Now look, we have this one already because this is the expression of that. We are dividing it By what? By now a simplified form of this one here. We have what? We have x times x is going to give us what? X done what? Very good. X squared. Then we have the minus. Remember, this is positive x and this is negative 5. Multiply the 2, you get negative 5x. Wonderful. This, ladies and gentlemen, is what you need to have if you're going to handle horizontal asymptotes. You cannot leave it in the other form and you obtain the values like we did for vertical asymptotes. Here, you must have them expanded. Okay? Now, after you knowing this one here, it's high time now you find out which method is going to be used. I told you, remember, we have two methods. All right? The first one is going to be by identifying the highest degree, and I'm going to talk about that. The second one is going to be by rearranging and solve quadratically. All right? Using the two would help us to get the values needed. Are you with me now? So in this case, please quote me. This is going to be now our method what? Our method 1. I'm going to call it method 1. In method 1, I come back here and check the highest degree or the highest power. You see, here in the denominator, the highest power is 2, isn't it? Can you all see the 2? All right? That's the highest degree. Okay? And then here we have, again, the highest power is 2. All right? So you find that the degree in the numerator, or the highest degree in the numerator, is equal to the highest degree in the denominator. Now let me stand straight and tell you something. You see, so many candidates fail to find the horizontal asymptote because they confuse this area with partial fractions. You see, when we go in partial fractions, we normally say that when the degrees are the same or are equal, say a case like this, we would consider it as an improper fraction. Therefore, by applying long division, we handle the improper fraction. You remember that. But this is curve sketching. In curve sketching, it is not improper. In curve sketching, it is proper. Are we together? And in that case, if it is proper, we do not apply long what? Division. Please don't forget. Don't forget, please. All right? Now, in this case, all we need at this point is to know that, well, once the two are equal, or if the numerator has got a lower degree, supposing this wasn't there, all right, we would say it is proper still. Why? Because the degree will be only 1, and this is 2, meaning that the one in the numerator is smaller than the one in the denominator. Still, the fraction will be proper. Or it is also proper in curve sketching when the degrees are the same or equal. However, if the upper number, the upper expression is of a higher degree, say 3, yet this is to maybe say 2, then that is when we say it is improper. Thank you. Now let's move on to this one here and see. You must know, are they equal? The horizontal asymptote can only be obtained when 1, the degree in the numerator is smaller than the degree in the denominator. When I said degree, I mean the power. When the highest power in the numerator is smaller than the power in the highest power in the denominator, then it is proper. Move on and find the horizontal asymptote. Also, when the power is the same, the degree in the numerator is the same as the degree in the denominator. Still, we're going to find the horizontal asymptote. Now, method 1. In method 1, after identifying the highest degree, of course, in the denominator is what? 2, isn't it? We are going to divide throughout by this part. Are you getting me? Yes, by this part. Why? Because in the denominator we first saw this is already proper in curve sketching. All right? And now, after knowing that it's proper, because someone is going to say, but sir, no. Our teacher told us that if the degrees are the same, it is going to be improper. Remember, that was partial fractions. This is curve sketching. Do not confuse the two. And I don't want you to fail this number because you've done what? You've applied the partial fractions in what? In curve sketching. you'll be having milk added to salt. Of course, milk has got to die, isn't it? Very good. Let's come back here and look at this. In method 1, I've said we are going to divide by this one here, throughout. Are you watching? Are you paying attention? Are you enjoying the lesson anyway? Do you have any question? Please keep the questions with you. We'll let you know what we're going to do. All right? So let's move on. We have y equals. Please observe this. Okay? I draw that line. Now, one of the other mistakes we normally make is this, or we normally do is this. We draw this division line to cover the equal sign. That is very wrong. Huh? Let me use this one here. If you do this, this is very wrong. Are we together? It is very what? Wrong. We cannot, the line must not cover the equal what? The equal sign. It must be stopping somewhere around there. Are you getting me now? Very good. Be mindful how you draw. Now we know also, if the equal sign is this one here, then our line for division must be in line with this equal sign, but not touching it. Have you got it? Very good. Now let's go. We have the numerator had x squared minus 6x plus what? Good, plus 9. Are you observing? Now remember, we are having also the denominator having what? X squared minus 5x. You people are very, very, very brilliant. Now we are saying we are going to divide by this one throughout because we first ascertained that, well, we are dealing with a proper fraction, a rational proper function. So in this case, I'm going to divide throughout by x squared. Here by x squared, there by x squared, there by x squared, throughout each of the terms of the numerator. Again, the same thing is going to be done in the denominator. Each of the terms of the denominator is divided by x squared. So I have divided by x done what? Squared. We stop there? Obviously no. If you stop here, it is wrong. There's a term that doesn't have a thing on it. This term here, if you don't put the x squared, it will become annoyed. You would have segregated it. It is not good to segregate values. Mathematics is a very, very, very enjoyable subject. Each of these letters, numbers you see here, okay, has a lot of jealousy in it. Whatever you do elsewhere must be done to it as well. All right? So we divide by what now? By x squared? Squared. Throughout. I hope you've understood that one now. All right? Very good. Now I want us to quickly go through what we do next at this very, very point. Are you paying attention? As we clean the board, there are things that I want us to always remember. Very, very important things. For determining, when determining the horizontal asymptote, don't forget that our y is what you're obtaining, isn't it? And the condition, just like we did in vertical asymptotes, here the condition is that x must tend to what? X must tend to infinity. And the values obtained are values of what? Well and good. Are values of y. I like that one very, very, very much. But if you have your pencil, you can also put those conditions somewhere. Circle them nicely because they're very, very important. You keep them deep in your heart. All right? And then we see how best we can understand this one very, very well. Let's move on and see how best we can continue with this very good question. Okay? We are looking at how we can determine the horizontal asymptote of a given curve using two different methods. However, these methods are going to give us the same answer. Very good. Let us quickly go through and then see how best we can determine the horizontal asymptote. Are you paying attention now? Remember, we ended by doing what? We ended by dividing throughout by x squared. Now we're going to simplify. The next step is to simplify. Don't leave it like this. First simplify it. All right? First simplify it. Let's go together now. Let's go together. Y equals what? I told you our division sign must be beautifully drawn. And you know what to do there. I won't mention anything else. All right? For those of you who have just joined us, this is Google TV class in liaison with e-learning Teachers Project Uganda. I can't forget my colleagues, Mr. Bonyo Kenneth. I have Mr. Tumwine Richard, wherever you are. I have Mr. Zimonia, okay? Mr. Odidi, Mr. Muhammad, I'm so grateful for the work you're doing for this generation. Now let's look at this one here. You see x squared divided by x squared, you know already. You know that x squared is the same as saying x times what? By the way, you can also use it to mean multiplication, all right? If I divide by x squared again, it's going to be x times what? Times x. What do you see? Of course, you know this x dies with this x, the other dies with the other. Do we get a 0? Automatically, no. We end up getting a what? We end up getting a beautiful 1. Here, when you divide this way, you get a 1. Minus, because we have a minus sign here, minus. Of course, we have 6x over x squared. And you already know if it is 6x over x squared. X squared is the same as saying x times what? X. And you know that this x here vanishes with this x up here. Okay? Now, what do we have remaining? You can see for yourselves that when we divided the other one, they vanished. We remain with the 6 over x. We come and put our 6 over x. That's amazing. All right? Then we have this one here. Can they cancel? Obviously, no. We have no x up there, so it can't cancel, unfortunately. So what we have now, we shall remain with our positive what? 9 over x done what? Squared. All right? So quickly, let's go down here and see how best we can also simplify. X squared over x squared, we know is going to give us good. It's going to give us 1. And then this is a minus sign. We put a minus there. 5x over x squared is going to give us what? This x is going to die with one of those x's we saw already. And we're going to be having what? We're going to have x over 5. Amazing. Now that we have simplified this one beautifully and wonderfully, class, what do we do next? It is time for us to quote our condition. To quote our condition. You see, you can only quote the condition when you've simplified. Are you getting me? When you have simplified. Good. Let's move on. We say as. We remember we said x must tend to what? To infinity. So we come and say as x does what? Tends, like we did, tends to positive or negative what? Infinity. Each of these ones becomes a 0. Don't forget that. Any x remaining becomes a 0. So this expression becomes 0, that expression becomes 0, this expression becomes 0 as long as x is tending to infinity. So what do we mean by this now? It would look like, it will mean that we have what? Y will be equal to what? 1 minus 0, because this becomes 0 now, plus again what now? Plus again 0. Do we continue? No. We divide now by what? We have our Mr. 1 here. Minus, this we said becomes a what? A 0. Why? Because our x is tending to positive or negative infinity. When it's tending to infinity, it makes 5 over x so small that it becomes a 0. And you know 1 minus 0 plus 0 is going to be what? It's going to be very good. It's going to be 1 over 1 minus 0 is also going to be 1. That is our y. Are we together? Therefore, you can see with your own eyes, okay, that our y is 1. Ladies and gentlemen, this right here, ladies and gentlemen, this one right here is our horizontal asymptote. All right? When we come back, I would like us to go through the second method and see, can we get y equal to 1? Don't forget to consider, therefore y equal to 1 is the horizontal asymptote. Thank you very much. Are we together? Look here. We have determined the horizontal asymptote using method 1, and we have talked about it very well. Now I would like us to go through another way we can find the horizontal asymptotes. Very good. Okay? Now look here. We said that if you're going to find an asymptote, 1, there are going to be values of x, values of y. Why? Because we are dealing with a horizontal asymptote. It must be cutting through the y-axis. All right? And then secondly, there must be values that make what? That make x tend to infinity. All right? Now in this case, in method 2, we are going to rearrange. We've already found out how we expanded this one here. Now what we're going to do in this kind of a case is we're going to put this in brackets like this, all right? And we're going to pick it. Or someone may multiply both sides by this. You multiply there and also this way. Are we together? Or you can just pick the whole of this one here and drive it this way. You know this is over 1. You can cross multiply. Don't show the cross multiplication sign. And then you have something. You see, when you do what I've just said, this is what you're going to obtain. Are you paying attention? Are you picking something? Good. Let's look at this. We said this implies that once I pick my denominator, remember this is method 2. We begin by working on this aspect, and now we're going to rearrange it quadratically. Are you paying attention? Very good. Let's take it. We have now y. All right? When this one moves to this side, to the left-hand side, it finds there y. All right? And therefore, we shall say y into what? Y into, we have x squared, okay? Minus what? 5x. All right? I hope you know where that has come from. Of course, when we take this one, this side here, we only remain with that numerator. We have taken away the denominator. It is now appearing on the left-hand side. Our right-hand side has the numerator, which is x, what? X squared, this one here, all right? Then minus 6x, which is this one here. And then we're adding 9, all right? The next step is we're going to remove the brackets, all right? Of course, we're going to multiply through by y here and by y there. And then we will rearrange and simplify, and then we'll be done. Let's go together quickly. You see, once we multiply this y times x squared, what do we get? We end up getting yx squared. You can even say x squared y. Why? Because multiplication is commutative. 2 times 5 is what? 10. Very good. What do you get when you multiply 5 times 2? Does the answer change? Of course, no. It is 10, isn't it? So you see, despite the change in the arrangement, our answer remains the same because it is multiplication. The same rule applies even in addition. 2 plus 3 is the same as 3 plus 2. So here we don't mind. You can have x squared y or yx squared. It's okay. It's perfect. Don't be there like, no, they said I must write x squared y. No. Okay? So let's go together now. When we multiplied y times x squared, we got that. Now we're going to multiply y times negative 5x to give us a negative 5. I can even say yx. Multiplication is commutative. All right? And now you observe that we have been able now to remove the brackets, all right, from the left-hand side. And now the right-hand side is having what? Our right-hand side, remember, has not been tampered with. So we have our Mr. X squared followed by minus 6x. And then finally, plus what? Plus 9. All right? And what we're going to do in this case is we want to pull or bring these ones the other side. And as we do so, we must move them in order of how they appear. All right? For instance, you're going to do what's called grouping. Grouping. All right? Let's group quickly. We have yx squared. Do we have any other number on the right-hand side, any term that has got x squared? Of course we have it. It is this one here. It is what? X squared. When I bring x squared this way, of course it is positive. It becomes a negative. We have negative x than what? Squared. So the group number 1 is done. The group of x squared is done. All right? Now let's move to another group. Okay? The group of x's. The group of what? X's. You see, on your left-hand side you have minus what? Minus 5yx. Do we have any x the other side? Automatically we do. It is not x squared because we have already taken it away. Imagine it's no longer there now. All right? We have a minus 6x remaining. Okay? And this is now what we're going to take the other side. And when we take it the other side, it's going to become a positive. All right? So we have positive what? 6x. Okay? You can see that the left-hand side has got no constant, but we still have a Mr. 9. These two have gone. We have 9 here, which is going to come this way to become negative 9. It was a positive, becomes a negative. And you see now, we've been successful in taking away everything this way. So there's nothing. We put what? 0. All right? We're going to factorize quickly. These two now, again in groups, we shall have what? You see when I do something like this, okay? The common factors are x squared for the first one, all right? The first group has got x squared appearing here and there, all right? So I factor it out, all right? And then now, after doing this, I'm going to come back and say, okay, when I take away x squared, what remains? I have what? I have y. Good. Then the y is going to be minus. When I take away x squared, I remember I told you there is a magical 1 there. So taking away x squared here means we remain with what? 1. So we put our 1 there. You factorize the first group, and that is good. All right? Let's move to the next group. The next group of x's, you see, have 1 is negative, and the other is what? Positive. Therefore, the negative or positive is not common. In that case, we're going to take the positive, all right? So I would have what? I would have the plus. Again, we're going to have something inside here because we want to factorize out what? X. Why? Because in this second group here, x is common, all right? I have what? This one is going to give me, I can start either way. I told you addition is commutative. I can say what is common here. I have the positive 6. Do you see the positive 6 now? When I take our x, I remember with my positive what? 6. I write 6. Okay? And then when we come back here, we have x taken away. When I take our x, you can touch it like this. You will see we have negative 5y. So the negative 5y is going to be written down here as negative 5. As negative 5y. Ladies and gentlemen, we have been able to factorize x as well. The only thing remaining now is the minus what? 9, which is going to give us a what? A 0. Now remember very well that we now need to apply the quadratic formula. However, in A-level or advanced mathematics, okay, you do not need to state it. We know you already know it. Are we together? You're going to simply apply the quadratic formula. If I can remind you, it is given by what? It is given by, we have x equal to what? X equal to what? Negative b, plus or minus what? The square root, are we together? Of what? Of b squared minus 4, good, ac. By the way, this one has got a special name. It's called the what? The discriminant. It tells us the kind of root we have. All right? And we're going to see how we're going to use it in the next area. Now, we divide all of this one here by what? By 2a. By 2a. So we don't need to study because we already know it. We know this is going to be representing a, this is representing b, and negative 9 represents what? C. So you just come and you know this is the quadratic formula in what? The quadratic formula in x. So we come and say, implying that x equals what? You see in the formula here we have a negative, all right? So we put the negative there. And then we have into what? 6 minus 5y. 6 minus 5y is positive, so we just write it and say we have 6 minus 5y. Are we together there? And therefore we have plus or what? Plus or minus, okay? The what? The square root, okay? What is our b? Our b is 6, which is positive 6 minus 5y. I come and put it here in parentheses or brackets. We have 6 minus 5y. Then what? Squared. Okay? And then we have a minus what? A minus 4. From the formula, we have a. We said our a is what? Our a is y minus 1. Close. Again, we bring now our c. Our c, from what we have here, is automatically negative what? Automatically negative 9. I put it in brackets, negative 9. Close. You make sure that your root sign covers everything. All right? And then down, we put our 2 into, what is a? Our a is y minus 1. All right? So we put our y minus 1. Beautiful. Now someone is saying, now master, really, you have two unknowns. You have x, you have y. What are we going to be finding here? All right? Now remember, we've said we are obtaining the horizontal asymptote. At this point in method number 2, what you're going to do as a brilliant student is to remember that at this point, don't simplify. Don't simplify. Because when you do, you'll be looking at something different. Another common mistake, another common source of error in mathematics paper 1 is people reaching this point here and they're expanding. All right? That's not acceptable. Let's look at this. At this point, you've done this. You just now state the condition. You say as what? As x tends to positive or negative infinity. Okay? Remember we said that whenever this one here tends to positive or negative infinity, the denominator becomes what? Becomes wonderful. Becomes 0. Good. So, as x tends to positive or negative infinity, the denominator is becoming a 0. It would imply, as this one does so, it would imply that what? That 2 into what? Y minus 1, okay, becomes what? 0. Isn't it? Obviously, the 2 divided by both sides is going to give us what? A 0. So, even if I don't put it there. All right? So, we have y minus 1 equal to what? Equal to 0. If you wanted, you can have your 2 divided by both sides. Still, it's going to give you y minus 1 equal to what? 0. When you take this one, the other side, you end up getting your beautiful y equal to what? Equal to 1. Have you seen? You see with them in method 1, we obtained y equal to 1, isn't it? In method 2, as we've done, you've seen we've obtained what? Y equals negative, y equals what? 1. So you conclude and say therefore, y equal to 1 is the what? Is the horizontal. Is the horizontal. Is the horizontal what? Is the horizontal asymptote. Is the horizontal asymptote. Asymptote of the what? The curve. Are we together? So as we conclude, in line with determining the horizontal asymptote, in method 2, please rearrange, okay? Obtain a quadratic equation in x, apply the quadratic formula, but the interest is not to solve for y. No. What we're going to do is we apply the condition that if x tends to positive or negative infinity, then the denominator becomes what? Becomes a 0. All right? When you get the denominator to 0, you end up getting this one, conclude and obtain the answer. All together. Ladies and gentlemen, I believe strongly you've understood this one now. When we come back, we want to give you an assignment and we want to find out whether you've been really paying attention. Dear students, thank you so much for having been so active, very attentive, and for the notes you've taken. Right before you now, we have an assignment for you. We want you to determine the asymptotes of the curves given below. Number 1, y equals 3x squared plus 2 divided by x squared plus 4x minus 5. All right? Number 2, y equals x minus 1. This is 1. Okay? X minus 1 into x plus 4 divided by x minus 2 times x minus 3. And the last number will be y equals 5 into x plus 1 all squared, in that case, other than 5, divided by 2x squared minus 7x plus 3. All right? Please do these numbers, attempt them, determine the asymptotes needed, and then from there, please, you can hand in this work on the contact here. All right? 0703 321 346. All right? This contact here is on WhatsApp. Do the number, send the work on WhatsApp, and then we'll be able to mark you. If you want to make inquiries in what we've been doing today, please feel free to inquire, call and inquire. All right? Google the TV Classroom, e-learning teachers project, Uganda. We thank you so much for having been attentive. Don't forget to sanitize. Don't forget to keep a distance. May God bless you.